Hello 108 students, Mr. McHugh here with you, fired up for section 9.6, page 8. We are going to go shoot down some bad guy missiles here. So my excitement comes from, I'll try to make the story fairly short here, but if you look at example 7, and it's on page, what do we got, 546, we talk about a missile being shot from the ground, has a velocity of what do they tell us here? Jesus, 40 meters per second. Okay, sorry, 40 meters per second. Notice that goes into the B term. The negative 4.9 t squared is in here, and it's plus 0 for the constant because it's shooting from the ground and a height is 0. Okay, so read this problem. They give us the S of t. Remember, that means distance. Again, I say this last time. S is distance, T is time. That makes sense. As the missile is launched, time is going by on the x-axis, height is on the y-axis going vertical. Okay, so as time marches on, after 1 second you would be here, after 2 seconds you would be up here. Okay, you kind of see the idea. We could give the heights. At some point, we would be at the halfway between when the missile is launched and when it lands down. It's always halfway. You will come up and hit the what? You got it, vertex. And I want you to find that. Okay, how many seconds before to achieve the maximum height? Okay, now you were doing this problem in 108 and you're like, yeah, another application problem I gotta learn, figure out vertex and line of symmetry, negative b divided by 2a, and take that, put it into the function and get the answer. But look, here's the story. In real life, I worked on Aegis cruisers, and we have radar. That missile would be launched off. Okay, during the Gulf War, Iraq was shooting Scud missiles out. We sending out radar signals. We track this rocket. Sorry, my rocket doesn't look too good. There's my rocket taking off. Okay, we realize it's a ballistic missile. We need to figure out its position and figure out this equation right here based on its speed and velocity, because we need to predict where this intercept point is of the maximum height, because at this point here's what's going to happen. These missiles are loaded up with fuel and they're angled and they're set off. They're like dumb rockets. There's no guidance to them. There's no maneuverability. They come up here to the top, then just like when you throw a baseball up in the air, gravity eventually starts to bring it back down. But what happens is these missiles are loaded up with mini missiles, and look what happens after they get to that vertex. Gravity can be used and they can launch multiple missiles off of that. So it's our job to have a standard missile, launch it and intercept and take this missile out, this ballistic missile out, before it starts to break up into multiple warheads. Okay, so I just try to give you a sense of appreciation. So lots of programmers, mathematicians, engineers all working together, tracking that missile, figuring out the profile of it, its trajectory, and the standard quadratic equation that it's working with. Okay, once we have that, we can start predicting as time goes along where the height's going to be. Again, in real life this will be three-dimensional, but it's enough to get the idea here. And we want to help out our Navy sailors out here. So what would we do here? We would turn around, take this equation, and identify the A, the B, and the C, which I did over here, and you're going to substitute and find a vertex. Vertex would be negative b divided by 2a, the line of symmetry. Plug them in. Look at the fairly easy math in this case. Negative 40 divided by 2 times negative 4.9. Answer 4.1 seconds. Okay, so when I launched that missile, we got only 4.1 seconds to figure out all these calculations, launch our missile, and pick this intercept point, and give enough time for our missile to make it there. Okay, not a whole lot of time. Now the question would be, what will that height be? Take 4.1 seconds, substitute it back into, for time, substitute it back into the quadratic equation like I did here. Here's your 4.1, and get your calculators, 4.1, grind it, plug and chug, and you find out it's 81.6 meters high. Now, in real life, these are thousands of feet up in the air, but it's the same principles are applied here. Okay, so at that vertex in 4.1 seconds, the height would be 81.6, and that's your answer. Okay, so that's my real life application. I hope you guys can appreciate that mathematics is used to solve many problems out there. Sometimes it's behind the scenes and we don't realize it, but it's out there and it's worked. Okay, so objective 5. Let's keep moving here. We got to keep going. Now we're gonna mess with you a little bit here. We've been graphing parabolas. What class? Vertical, right? Up, down. Line of symmetry has always been vertical. And so this is section 5, starts on page 546 also. And we want to talk about graphing horizontal parabolas going sideways to the left or to the right. Okay, and how this starts is you take a vertical parabola, which is y equals, and we're used to functions. Okay, now if I asked you real quick, is this a function when you have graphs going sideways? And the answer would be what? Hopefully you're drawing vertical line tests and you're saying nope, because you got stacked points. So horizontal parabolas or sideways parabolas are not functions. Okay, switch the variables. Y becomes x and x becomes y. That's how you trigger this whole mechanism. And so when you do that, you now have the variable x is isolated. Look at that. X is isolated. Here's your a, here's your b, here's your c, and now look what variable is the squared and raised to the first, the y variable. And when you go in graphing mode, you got to watch this. The a still stays over here. It's still the same coefficient. It's y minus k quantity squared plus h. Look at this. It's negative k plus h. Okay, now the vertex, thank God, is h comma k. Now that's nice to know, but look where the h is from. Look where the k comes. It's all backwards. Okay, so we're going to work on that in our next video here. So study that page 546, the purple box there, and my notes here. This is the kind of stuff you put into your hand notes. Okay, this is the kind of stuff you drill in there. So when you go to 143 and they start doing horizontal parabolas or sideways parabolas, you remember this. This all comes back. It triggers. Oh yeah, swap the variables out, h comma k, and we'll be good to go. Okay, so look at my notes here. Horizontal line axis is y equals k now. Okay, horizontal axis. It's y equals k. Here's the y-axis. It's going to be y equals something. If y is less than 0, then the graph opens to the left. If it's greater than 0, it opens to the right. And that, for me, that makes sense because on the x-axis, x is positive to the right, x is negative to the left. Okay, so we're going to get in the nitty-gritty on page 9 and dealing with those with the problems, but this was the setup for it. Okay, Mr. McHugh, going to sign off here now. When I see you, we'll be tackling page 9 and horizontal parabolas and how to do it. Okay, till then, take care. Bye.